I'm Stephanie Pedersen, and I did my project on, or I'm going to do my project on sauropodomorph histology this summer at the Field Museum. This project is funded and a part of the Trans-Antarctic Vertebrate Paleontology Project, which is stationed in Antarctica in the Trans-Antarctic Mountains, which are right here. And then this is a picture from Mount Kirkpatrick where Cryolophosaurus was found and some remnants of other dinosaurs as well. And as you can see, there's igneous rocks here that's actually basalt, but there's intrusions of sedimentary rocks, which is where the fossils are found. So there's 4 main dinosaurs that have been found here. The first one is Cryolophosaurus, which is the theropod meat-eating dinosaur found by Dr. Hammer. And then there's a sauropod dinosaur, Glacialosaurus, and then 2 sauropodomorphs that we still don't know what species of dinosaur they are. And I'm going to be working on one of the sauropodomorphs that they were found, and that is called, right now it's called Jolly Roger. It doesn't have a name yet. And it was collected in the 2010-11 season, and the skeleton's nearly complete, but it's so small that it's only about 1 meter long, and it was all found within the same block, all the bones. And so the skull that it has resembles a juvenile dinosaur, and it's probably more closely related to Ignavusaurus from South Africa rather than a juvenile Glacialosaurus, but that's part of what I'm trying to figure out by doing the histology is if it's a juvenile dinosaur and what it might be more closely related to. And I'm going to be working, you can't see the picture, but I'm going to be working at the Field Museum with Dr. Pete Makavicki on this. And so I'm going to be doing bone histology, which is basically the study of the microstructure of bones and tissues, and that can be used to determine the rate of formation of the bones, which can help determine the age that the animal died, the environment the animal once lived in, and the lifestyle adaptations, such as if it's a carnivore or herbivore. Some of the terminology used to describe the tissues is fibrolamellar, which is the woven matrix, and then there's the lamellar bone tissue, which is parallel striated lines, and then the Hebracerian system, which is a group of osteons within the tissues, and then the lag lines, which when you have the whole bone thin section, they grow in circles, and you can count the lag lines in order to determine essentially how old the animal is when it died. There's also several characteristics that help distinguish an adult from a juvenile, and juveniles tend to have a lot more fragile bones and also a more spongy appearance. They also have large orbits in the tissues, and the skull has short snouts and large brain cases, and the skeleton as a whole has a lack of fusion and separate pelvic elements. And then if it is a juvenile, you won't see any lag lines, so you're going to have to look more at the nature of the bone. And then as the animal develops, you start to see an increase in the skeletal robustity, a decrease in the orbit size, an increase in the growth of the crust if it has one, and also an increase in the number of the lag lines. So what is the histological process that I'm going to be doing? Well, first I have to pick out which bones that I want to make thin sections of. So I'm going to want to pick the larger bones, such as the femur and humerus and rib bones. And because making thin sections is a destructive process, I'm going to have to take all the necessary measurements and take pictures of the bones, and then it's important to also draw sketches so that I can draw on the sketches where I want to make the thin sections and take note of those measurements as well, and then also molding and casting the bone so we have essentially an exact replica of the bone. And then if the bone is not fully mineralized, it should be stabilized before we make the thin section so there is no empty spaces or holes in the thin sections. So then you have to embed the bone by combining a catalyst and a resin in a cup, and then you put the bone or fossil into a container and then pour the resin until the fossil is completely submerged. And then you put it in a vacuum to get out all the air bubbles, and then put it in the fridge until it solidifies. For the cutting process, I'm going to be cutting with an Isomet 1000 precision trim saw, which has a diamond blade in a water reservoir, and it has a small water pump to help lubricate the blade as it's cutting. And then I first have to draw the lines on the block so I know where I'm cutting, and label the specimens so I don't forget what bone it is after cutting it. And then I'll secure the block and fill the reservoir with cold water and then begin the cutting process. And then during the procedure, as I'm cutting, I should start the speed around 300 reps per minute and then increase to around 400 reps per minute to help the cutting go faster. And then after cutting, it's important to extend the arm 1.2 to 1.5 millimeters and repeat the cutting process in order to get more accurate results. And overall, each cut should be around 1 millimeter thick, and then it can be put on a slide. And it's important to maintain the order and orientation of the bone as we rinse in so that we can label it when it's dry. And after the cut's made, I need to mount, grind, and polish each section onto a slide. And then this process should be done at least twice on every single bone to get the most accurate results. And it's also useful to use many different bones so that we can compare and contrast in order to get the best results. And then I'm going to have to analyze each slide by looking under the microscope and count the lag lines if there are any. If there aren't, then I'm going to have to study in more depth of fibrolamellar versus lamellar matrix, and take note of all the different types of bone tissue I see, and then put all my information into a computer software and then hopefully deduct some conclusions. And so what I expect to find is a potential age for Jolly Roger and determine if it is a new species of dinosaur. And then there's my references and questions. Yeah.
At the beginning, you said that it's hypothesized that Jolly Roger was a juvenile, and is that based off like the skull? Is like are not all the bones like fused together, like sort of off infants are?
Yeah, that's based on. The skull resembles a juvenile, based on. I think it's more of the size than anything, and also Pete already had made a thin section of one of the bones, and there's no lag lines whatsoever. So I'm going to be looking at more different types of bones and stuff like that. Yeah.
So I thought like lag lines were supposed to represent 1 year of growth.
Yeah.
So if there's no lag lines, that means it's under a year old.
Yeah.
When it died? Okay.
Yeah.
But you said juveniles shouldn't have any lag lines.
Yeah.
A baby would not have any lag lines, but a juvenile means what? Under five?
I thought a juvenile was a baby.
No.
Baby's a baby.
Baby's a baby. Your juvenile is like a teenager
Um,
and an adult
well, we think it's a baby.
under 1 year old. That's okay. That's different than what you're saying. Okay.